So we've had 2 lectures in this chapter on force vectors, and we're wrapping it up today. What we really need to talk about is the dot product. And I believe the dot product is a review for you, is it not? I believe it is. Have you not used the dot product? Anybody not used the dot product? Everybody's used the dot product? Yes, no? Yes, okay. So as a review, you have 2 vectors. Maybe you express the vector A as AXI plus AYJ plus AZK. And then you have the other vector B, and then you can perform an operation. Typically the symbol is a dot in between the 2 vectors. So B would be BXI plus BYJ plus BZK. So these are coefficients or magnitudes in the unit directions along the axes of our Cartesian coordinate system, the XYZ directions. And so the dot product of A, I should put a vector on top of these, A dot B is equal to AX BX, the 2 X components multiplied, summed with AY BY, summed with AZ BZ. And what does it give us? It really gives us the magnitude of the vector A times the magnitude of the vector B times a cosine in 3D of the angle between them. If you put the 2 bases of the vectors together, if you have a vector A like this, here's the base, the beginning of it, and another vector B like this, then what is this theta? This is the angle theta between them. All right, so theta, as shown right now, right here, theta looks like, oh, it's around 50 degrees or 45 degrees. All right. Theta, if you had a vector A and a vector B, and what did I do? I tried to draw them so that they are in the same direction or parallel. Maybe I shouldn't make them the same length. Maybe I should make A a lot larger. In this case right here, clicker question, A dot, come on now, A dot B, is it going to be less than 0, meaning it's negative, equal to 0, or greater than 0? Answer A. I haven't started it yet. Give me a minute. B or C, and it's multiple choice, and now we're going to be on AA for the base, and you're off and running. Have to remember what is the cosine of theta when theta is equal to 0? What is the cosine of 0? Is it 1 or 0? One of them is 0. Is it the sine, hyperbolic, tangent, arcs? Okay, fine. It's just know your cosine and sines pretty well. And so the cosine of 0 is 1. And so by the formula, it would be the magnitude of A times the magnitude of B times 1. And, holy, come on now. Isn't it this? All right, let's do another question. So I have a different vector A. I'm going to draw this vector over here. This is my vector A. All right, now I'm going to have a different vector B. I'm going to put the ends of them together. Now I'm going to put it just like this, B. What am I trying to show about the relationship between vector A and vector B? They're perpendicular. Excellent. Now, 30 seconds, same options. What is the magnitude of the dot product of A dot B in this case? Is it less than 0, equal to 0, or greater than 0? All right, so let's see how we did. A lot better. What's the cosine of pi over 2 in radians or 90 degrees? 0. So there you go. Now, let's do another one. Let's do this one. A is off in this direction. Actually, let's change it up more. Let's do this one. A is off in this direction, and B will be off in that direction. A and B, like that. Same options. I want to know if I take A dot B for this case, is the answer less than 0, answer A, equal to 0, or greater than 0? All right, we're all in, so let's go ahead and look at the results. It's going to be negative. Why? So when you go theta greater than 90, the cosine is negative. True? If we take a look at the formula here, the A dot B is equal to, come on now, my pen is not marking up right, the magnitude of A. Could that magnitude of A ever be negative? Could we have a magnitude of a vector that's negative? That doesn't make sense. It's the magnitude, it's the length, it's positive or 0. Okay, how about the magnitude of B? Same thing. It's only the cosine of the angle that can be positive, 0, or negative. Okay. Now, you can see now if you get good at reviewing the dot product, you can see how you can use it to get components of a vector in a direction parallel to a given line. So let's introduce a new page and discuss that. So I have a line. I'll just draw it right here. That's my line. How do I describe my line in 2 or 3 dimensions? Let's stick to 2D so it's easy to see. How would you describe your line? Well, go back to this little guy. What's the instructor getting at when he draws this little U with the little arrow on it? What is that? It's a unit vector. So all I would need to do is get this line. Now I would get a unit vector. It really describes the orientation of the line. How would I get the unit vector? Go for 2 locations on the line, get the displacement vector, normalize it, and I've got a unit vector that describes that line. True? Now let's grab any general vector A out there in the world. Here's A. Okay? And what I like to do is I like to say, okay, I want the projection of A in the direction or a parallel to the line that's characterized by this unit vector U. So conceptually, it's better to go ahead and put the base of A, just move A, such that it's at the same location, the starting location, as U. Okay, somewhere on the line. And now, if I say I want to do A dot U, that will be the magnitude of A, true or false, times the magnitude of U, times the cosine of the angle theta between them. True or false? It's all good, right? Is this the angle theta? Okay. Of these 3 terms, either the magnitude of A, the magnitude of U, or the cosine of theta, which one of these 3 terms, and I'll label them. I'll say this is term, your first pick, A, answer A with your clicker, answer B with your clicker, or answer C with your clicker. Which one of those 3 terms are easiest for you to determine right now? Easiest. All right. Now, are we 100% correct? What does the word unit mean when I talk about a particular vector? The unit vector. What does unit mean? When I talk about a particular vector? 1. So, guess what the length of the unit vector is every day? Doesn't matter what the length of A is, the orientation of A, or anything else. So I would say that B is really easy to determine, is it not? Is it not? Okay, that's a major observation. So now, for this case, it just boils down to the magnitude of A times the cosine of an angle theta. I love right triangles. Do you like right triangles? Can you make a right triangle anywhere in this illustration? Where would it be? You would go at the tip of A, and you would drop down to the line, a line. Hold it. Should I drop it like this? This is my clicker option A. Or should I drop it like this? So that's another right triangle. I might like that one. Option B. I'm looking for a right triangle. Which one do you think is going to be most useful for me? Okay, is everybody in? I'm going to kill it at the time then, okay? You ready? Everybody's in. And the key observation was, and you say it out loud for the benefit of everybody.
With A, it makes the vector A your hypotenuse.
So the length of A, this is the best one, A. Let me go ahead and grade it. Hey, everybody knew that. Because what is the hypotenuse? That's the length of A. Magnitude of the vector A is the hypotenuse of that right triangle. And when I do the dot product of A dotted with U, it's the hypotenuse times the cosine of the angle theta. What does that give us? The magnitude of A times the cosine of the angle theta. Doesn't that give us, is that opposite or adjacent? I forgot. Opposite side, length, opposite or adjacent? Adjacent. So really what this gives us is the magnitude of the projection of A, or the magnitude of A in that direction of the unit vector. So what I could do is I could say, look, I want you to decompose A into two vectors. One is a vector that is parallel with a U. There's some notation that the book may have for that. And the other is perpendicular to the line characterized by U. Does that make sense? So if I said, give me a new vector, A, the parallel and the perpendicular components, well, I could say, well, this is going to be the magnitude of A times the cosine of theta times U. Isn't that what A parallel is? I picked off that parallel component of A to a line. And I re-expressed it as a vector. How would I get this part right here? Use the dot product. Use the dot product. Okay. And then once you want this A perpendicular, it's kind of like you go back to this equation and you just rearrange it. You just say A minus the A parallel. So I can re-express a vector A in terms of a component parallel to a line and perpendicular to a line. You can do it in 3D as well. I show it in 2D, but you do it 3D. So that's the vector components that are parallel and perpendicular to a given line. And then once we have done that or mastered that, then another very useful feature of A dot B is you can get the angle between two lines. That's not that hard. You could just go back to your equation right here. Maybe I'll scroll down. And so if I wanted to calculate the angle, I would say I'll take the vector A dotted with the vector V divided by the magnitude of A and the magnitude of B, and there you go. Or one thing you can do is you could say I'm going to calculate the ACOS of that, and that is theta. What is ACOS? Arc cosine. So I can get that angle theta using the arc cosine of the dot product of A dot B divided by magnitude of A and B.
Do you care if we write for A cosine if we do cosine -1?
Oh, yeah, that's another way of doing it, cosine -1. I've even seen ARC, COS, arc cosine, spelled out more. Okay, calculate the angle theta between two forces where the first force F1 has a magnitude of 800 newtons, alpha is this, beta is this, gamma is this, and the second force F2 is given by so much in the I, so much in the J, so much in the K. And notice that the units are consistent. We're talking about force vectors, so Newton, Newton, right? But you want to calculate the angle theta. How about if I give you a little while to work on that? All right? So go ahead and work on that for a while before I open it up. All right, I'm sorry about it, but we're just going to have to keep going, okay? There's a couple things I want to remind you of. I want you to talk to your teammates, the fellow students. I will change up teams later. It'll still be random like it was random at the beginning of class. But at the end of the semester, I'm going to throw it open and we're going to collect all this anonymous student responses like, was this person helpful on your team or not? True? And what percent of your overall final total grade is that worth? 5%. Okay? So be nice and help other people. Thank you very much. You're doing well as a class, but I really want people to interact. So let's go ahead and grade this. It came in at 115, 115. Okay, how do we calculate that angle theta? Well, there's two ways of doing it. Let's do this one. If I could calculate the unit vector in the first along direction of force F1, and then I could calculate the unit vector in the direction of force F2, and if I dot product, that would be the magnitude of the unit vector 1, which is 1, and the magnitude of the unit vector 2, which is 1. So let me just write that out. And the magnitude of U2, which is 2 times the cosine of the angle between. So really one of the easiest ways, you solve the problem a few times and then you observe, oh, this is maybe a little faster, that the theta is equal to the arc cosine of unit vector 1 dotted with the unit vector 2 in the directions that I want. Okay, now how do I get the unit vector for 1? Well, the magnitudes are 1, aren't they, for the unit vectors? That's equal to 1, and that's equal to 1. So, and how do I calculate, let's say, the unit vector 1, where this is F1? Is that going to be the cosine of alpha I, cosine of beta j, cosine plus cosine of gamma k? Is that true? Is that true? Yeah. And then for U2, that's going to be F2 divided by the magnitude of F2. And so what was, some people calculated the magnitude of F2. It's magnitude of F2 is equal to 120 squared plus 90 squared plus 80, or negative 80 squared. It really doesn't matter. You take negative 80 squared is the same as 80 squared. So, and then you take the square root. What does the magnitude of F2 come in at? 170? Very good. Yes, you're right, 170. And so this one was a little not as clean, true. So it was 0.70588 I plus 0.529412 J minus 0.470588 K. How many people, that's roughly how they did it? Maybe you did it a different way. You used the full force vector itself. That's fine too. Okay. All right. This wraps up chapter 2. And dot product is pretty mathematically rigorous. Actually, the whole chapter was fairly mathematically rigorous. A lot of review of trigonometry. And so just bone up on it. Make sure that you're comfortable with the math, okay? I'm ready to jump into chapter 3. And if time permits, I'll come back and solve more problems in chapter 2.